Hi everyone. Today we'll have a completely new section of ME231. So until now, we discussed about how to obtain the maximum stress out of the statics and out of stress strain relationship and etc. However, from now on, we'll talk about how we can predict the deformation and deflection of structures. Okay. Before beginning the first lecture of deflection of beams, let me give you a review of entire coursework flow because we finished the first goal of this coursework, ME231. So as I told you in the maybe first class of this course, two goals of this course are following. The first goal is predict the failure by obtaining the maximum shearing stress, maximum normal stress, and compare those with material property, which is allowable shear stress and allowable normal stress. Okay, so if the maximum shearing stress or maximum normal stress turn out to be larger than the material's strength, then you're gonna say that the structure will fail and it's not mechanically reliable. That's what we have done until now. So for that, what we have done was for chapter 1 through 6, we discuss about these reactions, to force and to torque one by one, and we also discuss about like how we can obtain normal stress out of normal force and moment torque, or we also discuss how to obtain the shear stress out of vertical shear force and torsion torque T. Okay, and then in chapter 3 we discuss about how to combine normal stress and shear stress and using the and how to do stress transformation and strain transformation based on Mohr circle. And then in chapter 8, which is the last chapter, we try to combine all the knowledge we have accumulated from chapter 1 through 6, chapter 7, and solved relatively quite complex problem. Like some problems have like a three of these four reactions, some problems have all four reactions, and after obtaining those four reactions, we also found that the combination of normal stress and shear stress is also location dependent, and you have to have the intuition, and you have to have like all the complete knowledge about like chapter 1 through 6 to handle the problems in chapter 8. So the challenging final exam will be, even though you have taken midterm exam, you should have memorized and understand the concepts we have already covered in midterm to do a good job in final exam, because final exam will cover chapter 8. Okay, so that will be the challenge of your one of the challenge of your final exam. Then with chapter 8, it was done, our first goal was done, predict the failure. And then from today we'll move on to the second goal of this coursework ME231, which is predict the deformation. Actually we have done like a deformation and deflection prediction until now, little by little, under the normal force. We discuss about how much displacement we can expect under the torsion. We also discussed how much twist angle we can uh, have given length and given the cross-sectional area and material property and the um, applied torque T. Okay, now however, if you recall like what we have done, we, even though we learn about like a shear force and moment which give rise to shear stress and normal stress, we haven't learned about prediction of beam deflection. Okay, so we haven't discussed about beam deflection, and that will be the topic of this lecture and this chapter, which is chapter 9. And in chapter 9 you will derive so-called Euler-Bernoulli beam theory, and based on that, by combining the Euler-Bernoulli beam theory, which is linear differential equation, and by combining the boundary conditions from ME231, we'll understand and we'll see how to obtain the shape of the uh, uh, shape of the deflected beam. Okay, and then until like chapter 9, what we're gonna do is we'll rely on local mechanical equilibrium and the free body diagram, uh, so-called like force equilibrium and torque equilibrium method. However, in the chapter 11, which gonna consider energy method, instead of considering local force equilibrium, local torque equilibrium, we'll discuss about how to approach the beam deflection and structure deflection problem based on energy approach. Okay, so this will be the topic of entire ME tutorial, and actually there is chapter 1 and chapter 10 which considers buckling, but buckling will be handled in the solid mechanics 2, like like the other semester, in advanced undergraduate solid mechanics course, we'll learn about how to handle the buckling problem. Okay, so with that, I gave you the review of what we have done, and I also give you overview on what we're gonna do from now on until the end of this course. Okay, so with this big picture in mind, let's start our discussion on new chapter of this course, deflection of beam.